Okay, so let's get started. We're going to be taking a look at understanding our power enrichment fuel programming within our Gen 3 engine control modules. This is what we enter into when we go into full throttle conditions. We richen up our desired target lambda mixture from 1.0 or stoichiometric at idle and part throttle cruise to something richer so that we make the best horsepower and torque production out of our engine, but also keep our engine safe so it doesn't knock or pre-ignite. Now, what we command in the power enrich is going to change depending if we're naturally aspirated or we're forced induction. So we're going to talk about both situations here in this training module. We're also going to learn how we can enter into our power enrichment mode sooner by changing some of those conditions that we have for programming. We also want to make sure whatever we're programming for the power enrich, we're also pairing that and making the same changes to the optimal power mode in our VCT scheduling because they go hand in hand. If we're entering into power enrichment mode, we don't want to be running at 1.0 stoichiometric target lambda. We want to be richening it up, and having the power enrichment and the optimal power mode match each other in terms of the conditions just makes sense. So I'll show you how to do that here in this training module. Let's jump in and take a look at a stock equivalent file so we can find where the power enrichment tables are going to be for programming, and we'll talk about how this is going to work. It's a pretty straightforward strategy, but we're going to break this down to make sure it's very clear how this all works. And then we're going to take a look at a data log so we can see what to look for when we enter in power enrich, and then finally updating power enrich and VCT scheduling together so you can get into your full throttle power band a little bit sooner. Okay, so let's go up here to file. Let's go to open. Let's go up here to 2020 Mustang GT stock. Doesn't matter, any stock files will work. Let's open up this file. We'll go here to engine, and we're going to move from general over here to fuel. And from fuel, we're going to move from our general area here over into our power enrich tab. Now, this is where we program and change the power enrichment. Now, how does the power enrichment work? We're going to find we have this watt lambda table here. So this table is going to be based on engine speed versus engine coolant temperature. This is going to have a desired target lambda mixture that we want to run when we're getting into higher throttle angles. We can see that this is going to be commanded here based on our fuel enrichment pedal. This is going to look at engine speed versus your pedal position, so your actual pedal in the car, and this is going to be 90% throughout the entire table. Now we're going to learn how we can change this so we get into the power band a little bit sooner, but what we'll find is that once we have exceeded this pedal position, we go from 1.0 lambda target at idle and part throttle cruise conditions into the watt lambda table, and this establishes our new desired target lambda mixture. We can see this changes here. Lower engine speeds, we're commanding 85 lambda. Higher engine speeds, we command about 82 lambda. We richen things up to number one, again, make the best torque and horsepower output out of our engine, but number two, to make sure that the engine is safe and it doesn't get knock or pre-ignition. Now, the reason why we find it richens up here toward the top of the table, typically because the engine responds to a little bit richer target lambda mixture, but also because we have, if this is a stock file, we have cats in the exhaust. So we need to make sure we're cooling the cats down at full throttle, and that's going to be part of our strategy here. And if you do cat deletes, you can run a little bit leaner lambda mixture here and usually find a little bit of power by going in and leaning out the mixture slightly. Usually not going above maybe 84, 85 lambda at these higher engine speeds. But that's the idea of this table. Now, how does this actually work in terms of our air and fuel model? Now, we've talked about lambda, air fuel, and stoichiometric in another tutorial, but we're going to just revisit it here real quick just so we can see how this new command at lambda actually richens up our fueling delivery to the engine. If we take a look at our Excel spreadsheet, let's jump in here. We're going to have this tab here called Stoich. This is what we visited when we were talking in that lambda, air fuel, and Stoich tutorial, but we're going to be using this here in this tutorial as well. So what we're going to find is that at idle part throttle, we command 1.0 lambda. That's where we run in our closed loop, and that's what we want to run to get the best emissions and reasonable power output out of our engine. So that's traditionally where we always run things. We'll find that the way that the air and fuel model work is that if we know our air mass, either coming from the mass airflow sensor or the speed density map pressure calculations that go on, so whether your F-150 speed density or your mass airflow with a Mustang, you're going to know the air mass. So if we know the air mass, then we need to take air mass and we need to divide it by a target air fuel. That's going to give us a fuel mass, and then we can convert a fuel mass into an injector pulse with knowing all the injector data. So what we need to know is air mass and target air fuel. Now, the way we establish a target air fuel is knowing what the desired lambda is going to be. Let's just keep this simple. Idle part throttle, that's going to be 1.0 lambda. But we also need to know what the fuel STOICH is going to be. So different blends of petrol and ethanol have different STOICH values. And that is going to be allowing us to compensate for the ethanol in a fuel system. So looking at this real quick, if our ethanol content is 0, then our STOICH AFR here is 14.7, which means that the target air fuel, let's say at idle and part throttle, would be 14.7. So type in here 14.7, okay? Simple enough. So if we know the air mass, we know the target air fuel, which is going to be fuel STOICH multiplied by the lambda, gives us target air fuel. We know fuel mass. We can convert fuel mass into an injector pulse width, knowing the injector data, and that's going to send it to either set of the injectors here for our Gen 3. So we know we have port injection, we have DI injection.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.